following up on from your answer, and using this analogy with System 1 and System 2, you work a lot, especially in the 90s and 2000, about ILP, this using logic and learning at the same time, and it was this more like a reasoning and consistent approach to even doing induction and combining it with deduction. You have both things in the same package. That was a great program. It was very. It was some moments even in when ILP was co-located with ICML. I think it was 97 or 99. Mm-hmm. And they were more or less the same communities. And this community was very strong, especially in Europe and even in Japan. And now perhaps this has been diluted a little bit, or was diluted for a few. For 1 decade or so, and it's more like let's try to solve System 1 now, and I would say that maybe that's a comeback. What do you think, especially related to this explainable AI, where we need some interpretable models? It's not only we want to explain things that are not understandable, but also maybe we can try to do it initially as symbolic, again a little bit of symbolic learning.
Mm-hmm.
Again.
Yeah, I think there has to be a comeback, because I think the kind of System 1 approach gets you only so far, whether it's 80% or 90% or 95%, depends a bit on how you measure it. But yeah, you are right. The ILP, inductive logic programming, this idea that, okay, we knew that we could mechanize deduction, the kind of mathematical reasoning, although there is still a difference between generating possible deductions and selecting interesting ones. That's still kind of an open problem, because mathematicians don't spend their days proving that 3 + 4 = 7, because that's not interesting, although it's true. So even there we have this thing that we generate possible deductions and then we select interesting ones, which is very much the view that I developed in my thesis with induction as well. You have a stage of possible inductive hypotheses, like in the version space, and then you need to select ones. So nowadays, inductive logic programming combined these ideas. Stephen Muggleton had this really exciting, and Ray Buntine had this really exciting idea of induction as a kind of reverse deduction cycle. That was incredibly exciting and a very influential paper for me, and that was for a while very fashionable, very dominant, and it was in a way ahead of its time, because I think what's happening now with deep learning, because deep learning went through a phase like that as well. The key ideas were invented decades ago, but they couldn't make it work on a bigger scale. Now we have bigger computers and better algorithms and so on. So it's not impossible that something like that works. It may happen for ILP as well. But I think the problem with ILP was that you needed to understand quite a lot of the logical backgrounds before you could see what was going on. And it always was more of a European thing than an American thing, because Europeans had Prolog, which was logical reasoning. Americans had Lisp, which was functional programming, and they were just different worlds, and they never really merged. But I think I still teach those ideas to my students, because I think the ideas are important, whether you do it in Prolog or in Lisp or in another language or in Python. That doesn't really matter. But the ideas of which bits of reasoning can be mechanized and which bits are the heuristic side of things, where you have to estimate or guess what is the best answer, I think that picture still remains. So I think it's important to make people aware of that. Not everything is System 1. Not everything is going to be solved by deep learning, and we still need the reasoning side to think. And actually, ironically, the ingredients of AI, whether they are, let's say, statistics or Bayesian reasoning or logic, humans are not particularly good at any of those. because of our system one. We tend to forget about the base rate, or we go for the intuitive answer. So logic is hard. Bayesian inference is hard, even for us as humans, but it is there. Maybe even just at the meta level, you know, like Leibniz said, well, if we have a disagreement, calculemus, let's calculate. We can decide who is right. In a way, this is what the scientific method is, right? So let's reason about it. It's hard. It's not something that everybody can do. You need to train years to be a scientist. But yet it is a very, very fundamental capability that I think makes us human in a way. So so for me, even if I'm doing pure machine learning, this idea that there's always going to be reasoning, you need to communicate with humans, you need to involve humans, that is always there somewhere at some level.